So next I would like to work on the water. So I'm going to set up a little lake here in the middle of the grasslands. Next I'm going to adjust the position of the lake and change some of the water body lake settings. And under fall off settings, I'm going to change the fall off from angle to width because I like this look more. And then we're going to create a new PCG graph for the lake and put it in our parent graph. Because if you don't put it in the parent graph, it will not execute. So I'm going to grab a get actor data node and change it to all world actors and filter it by class and put the water body lake class here. So first let's try to get the points that are on the interior of the lake by using a spline sampler and setting it to on interior. And then transforming the points with an absolute scale. These nodes here are basically going to define our lake mask. And we want to output this lake mask to be able to use it in other subgraphs. So on the output node, I'm going to create a custom pin. And I'm going to call it mask and connect the transform points. Let's see if this is working by re-enabling the grassland and actually connecting the mask also in the grassland graph. So right before the static mesh spawner, we need a difference node. Same goes for the trees here, and set it to binary. For now, we just need to create a custom input pin for our mask, which I'm going to call mask also, and then just connect it to the differences here. Trying to tidy up a bit. And then I'm going to activate also the static mesh spawner for the trees. Okay, the reason that the difference is not working yet is that I forgot to connect the mask to the actual input mask of the grassland graph. So we're going to do this, and then we should see the difference is working. So next what we're going to do is spawn some rocks and foliage assets around the lake. I also want to add a projection node here because sometimes the points of the spline sampler can end up actually being under the lake, and the projection node fixes this. And for this, we also need to connect the landscape pin in our parent graph to the PCG lake, and then also connect them in the lake graph. So now you can see that the points are getting projected on our landscape, and actually we need to adjust now a bit the bounds of them. I think I'm going to go for 1 here and 10 on the z-axis. So next we want to create some foliage around the lake. For this I'm going to duplicate the spline sampler, and I'm going to set it to on spline this time, and also increase the subdivision per segment, or maybe even subdivide it based on distance. And now what I want to do is create a point grid, put it again to local, and then copy it to all of these sampled spline points. We're also going to project these points here actually, and debug this node. And in order for these points to actually show up, we also need to reset the transform points and set it to an absolute scale. I found that this was helping here in this case. And by adjusting these grid extents here, you can decide how far you want to reach the point into the lake. So let's maybe put it to 750. So right now this looks still way too uniform. So I would actually like to offset the location a bit with transform points. Just maybe between minus 500 and 500. I found that some of the points here were still floating in space, even though I have no offset on the z-axis. And I believe that's because of the way the point grid is set up. But an easy way for fixing this is to just switch the position of the transform points on projection node. And then they are all going to be flat on the landscape. Next, I would like to create a density falloff based on the distance to this outer spline here of the lake. So I'm going to add a distance node. For the source, we take our points here, and for the target, we take the actual outer spline here. And also going to set it to set density again and see how it looks. To make it a bit more visible, you can change the debugging mode here on. You can actually do this on every node individually, and it doesn't influence the actual bounds of the point. So we can change it here from extents to, for example, absolute. And then we can set it to a scale of 0.25 or 0.15. And then we can see what's going on here. So yeah, the falloff is looking decent, I think. Maybe let's see how it looks with 1000. And now we're going to filter it with a density filter, and we're just going to keep the points that we would like to, depending on how far we want the foliage to go into the lake. Then let's randomly decrease the density of these points here by filtering them with a density noise and adding a static mesh spawner. And if you figure out a way how to add multiple assets at once here in this mesh entries array, please let me know in the comments, because that would be really helpful. Now I'm just fine-tuning some settings here. This is the density based on distance that we can filter here. So if we increase the upper bounds here, it's going to reach further into the lake. And here we can control the overall density of these points. And I also want to offset everything a bit because it looks a bit too uniform. Next, I would like to add some big rocks, and for this I'm going to use the same general points that we used for the foliage. Just going to apply different filters. For these big rocks, I would like to use the mesh sampling graph that we created in the first part of this tutorial. So I'm going to drag it in here and decrease the amount of points. And also adjust the scale of it, 0.1 and 0.4, but it depends on the rock asset that you used and how you set up your subgraph. Okay, now in this subgraph that we created in the first part of the tutorial, I would now also output a mask so we can mask out the foliage here. And before the transform points, I'm gonna add a bounce modifier and then check if we can match this shape of this rock here. And then create an output pin, call it mask again, and connect it to the transform points of the initial mesh. If we turn on our foliage now and create a difference node here before, then we should be able to filter out these rocks. I think I would like to make them a bit bigger. And in this case, also some self-pruning so they don't clip into each other. And now I'm just going to spawn some smaller rocks based on the initial lake interior spline sampler here. So I'm going to branch off after the projection here. Filter it a bit. And I'm just going to use the same ones that I'm using for the cliffs here. In this case, I also want to add rotation on the other axes, because I made sure that these are all closed meshes. Because sometimes from megascans you get assets like this, which are just open on the bottom, and these ones you should just rotate around the z-axis, of course, because otherwise you're going to see the opening. But you can also filter in Quixel Bridge by closed assets. Here you see the relative size next to a humanoid, and next to it you see if it's a closed asset or an open asset. So next I would like to work on a system to create pathways into the forest and to spawn assets dynamically around it and exclude all the foliage. And then when you change the path, everything is adjusting dynamically. So let's create a new PCG graph and also put it into the parent graph. Then what I want to do is create a new actor under basic actor. And then I'm going to click this little icon here to convert it into a blueprint class. And I'm going to call it BP forest path. In the blueprint, we're just going to do one thing. We're going to add a spline component and save it. And we can close it. So what we're going to do is we are going to take the path here, instantiate points on the spline, and project these points onto the landscape. So it doesn't actually matter that we align the path manually to the landscape. We can just like sort of have it floating here above the landscape, and it will all snap to the landscape once we do the projection. So let's create a get actor node, set it to all world actors and by class, and select the newly created class, forest path. In order to fix this warning here, I'm just gonna reopen this graph here, and it should be gone. And then we need a spline sampler and a transform points node. And for this, we want to set the absolute scale and put it to something like 150 on the y-axis. Also uncheck the uniform scale. Now what you can see here is that the y-axis will now define how wide our forest path will be. So we can also set it in a range to maybe have some variation between 150 and 200. And then we need to increase the subdivisions. I want to subdivide based on distance. Maybe put it to a value of 5 or something like this. So now let's project it on our landscape. And we need to assign the landscape in the parent graph to our subgraph. And now you can see already the path being aligned to the shape of the landscape. And I also want to adjust the scale on the z-axis a bit here. Okay, now so let's output this as a mask and use it as a difference mask in our other subgraphs. Like before, I'm just creating a mask pin on our output node of the path subgraph. I'm just going to connect it here. And then we need to do some changes in our forest, grassland, and slopes subgraph. So the grassland is already set up to accept masks. So we can just add it on top of it. The forest is not set up for this yet, so we need to go into this graph and change it, which takes a bit of time because in front of every static mesh spawner, we need a difference node. And then we need to actually connect it also to the forest. So I was just debugging this a bit, and for me, in order for this to actually work, the projection has to be before the transform points. It was not working the other way around. And now, as you can see, there are no foliage assets or trees where the path is going. Let's actually extend it a bit and add some spline points here. Let it calculate, or if it doesn't, then force a regeneration. And as you can see, we're creating a path through the forest here. Now I would like to apply the masking also to the slopes subgraph, because for the grassland and the forest we already have it. Again, I'm going to create an input node here, an input pin. Since these are all originating from the same scale by density, I will just do the difference right here, so we don't have to create 3 separate difference nodes. So next we're gonna scatter some points on this spline here and fill it with debris, some rocks, some twigs and other pieces of forest to make it look a bit more natural and interesting. Again, I would like to be able to filter out just points that are on the edges of the path, as well as points that are scattered all over the inside of the path. So for this, we're again going to use a point grid to get like a base set of points that we can then work with and filter and create these edges and insides of the path. Create point grids, copy points. And as the target, we are taking these projected points of the spline sampler. Then I'm going to set it to local again. And let's check if we already see something here. No, actually, we also need to project these points back on the onto our landscape, because they are a bit messed up right now. And then what I want to do in order to fix the points here a bit is change the settings on the create points grid. And then I want to randomly move around the points here before projecting them. Okay, so now let's work again on the gradient. Create a distance node, set the density, and the target is the projected spline. And here a maximum distance of around 350 should do. And then we can filter out the edges of the path with a density filter. And now we're going to use these points to spawn certain assets on the edge of the path, and then we're going to have different assets towards the middle of the path. I think I want to spawn some tree stumps and rocks on the side of the path here. And then either do some additional filtering here based on noise like we did before, or you can also adjust the density of the points here in the create points grid. We are assigning some random noise again and filtering based on some lower and upper bounds. And also set the bounds so we can have some self-pruning. And also create some variation here in the transform parameters. And now we're going to use this here as a base and create the other static meshes. So we just need different density filtering values to then not get the edges, but rather the inside of the spline now for some rocks or debris. So we'll just copy this. And then I'm going to add one by one all these debris assets here, which I hope they're going to fix, that we can like add multiple of them at the same time. And now I just want to adjust this density filter here to get the points on the spline and not so much on the outside here. Then filter them even more to make them less dense. And then don't forget to change the offset here or to reset it to 0 if you also copied the whole node set here, because otherwise the twigs are just going to end up under the landscape and you won't see them. I mean, for this, we don't really need self-pruning. I think I'm fine with assets clipping a bit into each other here. It's not going to be visible so much. So I'm just going to delete or deactivate the bounds and also the self-pruning here. And then add another layer on top of it. Okay, so let's actually check if we can get the path also working in the grasslands by just extending it. The last adjustment that I would like to make to this path is adding some decals to it. So I'm going to create a new decal actor, and then under Megascans in the decals folder, you will find all the decal materials that you imported from Quixel Bridge. So I'm just going to drag it in the slot here. and we're going to adjust the size in the PCG graph because we're going to spawn them procedurally. So all I need to do is save this as a blueprint and delete it here for now, and then open up the path. So we're going to create another copy here. Also clean up a bit. Okay, now we don't need a static mesh spawner, but we need a node called spawn actor. And inside here, we're going to specify which actor. So I'm going to type BP decal fallen leaves. And then under option, we're going to select merge PCG only. And adjust the rotation. So -90 on the Y is what it is for me here at least. And then I want to adjust the scale of these decals. So let's just duplicate this one. Call this one tree bark. And this one here wood. And then I'm just going to copy this here and change some parameters around and assign the new decal. And then I would like to overlap it a bit more here because this line of where the debris spawning ends is pretty clearly visible. So I'm going to adjust these parameters here. All right, so as the last technique for this little forest scene here, I would like to create a sort of hero tree that is a dead tree that is overgrown with vines and some moss. In order for this to work, we are going to create a new blueprint class for us that will then be sampled with get actor data in the PCG graph. I'm going to call it hero dead tree dummy because it's not the actual asset, it's just like a dummy actor. So then we can set the get actor data node, but we also need to add it still to our parent graph. Otherwise it will not execute. And then we're grabbing a reference to this actor. Let's see if we actually receive the point. There it is. Okay, let's project it on the landscape. So the only input that we would need is the landscape data that we need to grab from the parent graph, assign it in the parent graph. So let's project it on the landscape and spawn a static mesh here, which is going to be the dead tree that I have here. So I want to adjust the scale here a bit. And now we need a mesh sampler and use the same mesh here. And then we're just taking these points and copying them on the spawned mesh here, as we already did in the first part of this tutorial series. Now I would like to decrease the sampling radius a bit to create more points here. And then we're going to filter them by normal. Normal to density is what we need. And I'm going to take the downwards facing normal and then filter all the points. Okay, let's see if we can work with that. Start with the static mesh spawner and get some vines here growing. It's probably going to be fixable with the transform points. And I'm just going to assign a absolute rotation and then filter the points even more. Now what I would also like to do is to grow some additional plants on the stem of this tree. So let's copy this one here and the filter. Actually, all of these. And here I'm going to set the normal to let's say forward facing, disable the static mesh spawner. Facing in the X direction seems to be this direction here. And I'm just going to merge them with the other directions as well. I found this to be the fastest solution. Maybe there are other ways of doing this. So I'm just going to create all of the directions in the XY plane. Right? And -1. And then I'm just going to union them. Okay, and now I'm going to create a distance node, and I want to compare the all of these points here against a single point in the middle of the tree. So we get a fall off, and we'll then be able to filter out points that are on the branches, because I want to focus on points that are on the stem here right now. And yeah, actually we should be able to get this single point from the projected dummy point that we are getting from our blueprint. So I'm going to plug in the projected point here. Tick set density again. Okay, now what I want to do is I want to transform the point a bit before. And now I'm just going to change the scale of it to stretch it along the tree and also make it a bit thinner. And now let's check the distance again. Now that we basically separated the points that we don't want to use for the mossy patches or whatever, points on the branches and the points on the stem, we can actually use it to spawn some static meshes on it. And actually I forgot to filter it. Density filter, and invert the filter because I wanted to put them here rather. And currently these static meshes are not spawning because the density seems to be completely 0 right now. So I'm going to add a density remap node. And just going to flip these two here to remap it from 0 to 1. And then also do the usual density noise filtering on top. Adjust the scale a bit and the rotation. And now also adjust the scale and maybe a bit here of these vines. Also rotate them a bit to break up these patterns. Okay, then let's also create a mask here like we did before. Find the output node, create a new pin. And yeah, here I would like to adjust the bounce a bit before I put it in the mask. And then plug it in all these subgraphs that you would like to use this mask. So if we move the dummy around now, our graph needs a refresh. So just force a regeneration. And then it's going to spawn in this location here.